Fritz Zwicky studied physics and became fascinated by supernova and astronomy. Some of his important claims made in the history of astronomy will be discussed in this video. In 1927, Zwicky looked at theoretical probabilities to explain a redshift. Put simply, Zwicky considered mass m and mass M. If m travels at a high constant velocity, it will not move much off the traveling path, although attracted to M. This information can determine the force of attraction of both masses, and if m moves off its path, there will be a transfer of momentum to M. Looking at velocity of the speed of light, light being attracted to another mass will also lose momentum and can cause a redshift. This results with the emission spectrum displacing, essentially a shift of spectral line. Published in 1934, Zwicky and Bae drew conclusions on cosmic rays coming from supernovae. 1. They concluded that massive atoms can be lost by kinetic energy and electromagnetic radiation, and nuclear packing fraction cannot account for this loss of energy. 2. Zwicky and Bae found that supernovae emit cosmic rays, which advanced knowledge on supernovae and the formation of neutron stars from normal stars. Published in 1937, Zwicky made a claim for the existence of dark matter by observing the Coma cluster, which was imaged using the 18-inch Schmidt telescope. This telescope is best suited for observing clusters of galaxies because of its high speed for objects of high luminosity. Thus, it's able to investigate galaxies. Zwicky thought the cluster consisted of viralized galaxies, as the mass was much greater than the stars found in discrete galaxies, which led to further interest in the Coma cluster. Supporting evidence also exists of clusters being space fillers. Also published in 1937, Zwicky thought of a way to find the massive extragalactic nebulae. He realized from observing luminosities, concluding evidence was lacking to determine mass, but a model that considered average angular velocities measured from the center, outside the core, and all particles at specific points, he can determine a measurement for mass. Published in 1956, Zwicky concluded information regarding the distribution of nebulae. He found that high weight values in nebulae can represent clustering. Not all nebulae have the same mass, and clustering can cause nebulae to be separated from others. This could help explain differences between spiral field, globular, and elliptical nebulae.